So for all of these systems that we work with, the solution for any of them can be found through graphing. And what you're looking for, again, is the solution of the system. So that means you're looking for two values that satisfy both equations. Now, since these are linear and in two variables, we're talking about two lines when we graph them. And so what we're really looking for is a point shared between the two lines. And the only way that could really happen is if they cross at one point or if they're the same line, which we'll talk about later. And so right now, when there's one solution, what you're looking for is that one point where the two graphs cross. So there's two ways to find that point. One is by hand, and one is with the calculator. We'll look at the calculator method in another video. For now, we'll look at doing this by hand. You won't be doing this by hand too often, but later on, we'll be working with large systems of linear inequalities. And so being able to do this by hand is going to make that much easier because that can't always be handled as nicely with the calculator. So I'm going to show you kind of a shortcut perhaps for graphing these. And one of the things you want to do first is solve for y in both equations. So here the first one's quite easy to do that. It'd be y equals 13 minus 3x. For the second equation, because there's a 2 there, we got a little more work. So 2y equals 6 minus 2x. And so y is going to equal, divided by 2, 3 minus x. Okay, so here's the system I'm going to work with where everything's solved for y. The next thing you want to do, and I'm going to label these 1 and 2, is find the intercepts. If you can find the intercepts, then graphing this is going to be much, much easier. And so if I find the intercepts, I want the x-intercept and the y-intercept. And so I'm going to make a little line here, do our x-intercept, our y-intercept, x-intercept, y-intercept. So remember, intercepts are where the graph crosses that particular axis. And so if I have 2 points, I can draw the line. And often intercepts are easy to find. For example, this is in the form of mx plus b. The plus would be 13, and the m would be negative 3. And remember, b always represents the y-intercept. So here the y-intercept's actually 13, and here the y-intercept's actually 3. Now what about the x-intercept? Well, that's the point where y equals 0. So what I want to do here is I want to solve for n2. I want to solve 0 equals 3 minus x. Well, that would mean that minus x equals minus 3. In other words, x equals 3. So this has the same x and y intercepts. And then the same thing here, I want to set y equal to 0. So I'll do that work right here. 0 equals 13 minus 3x. And so we get negative 13 equals minus 3x. So x is going to equal 13 over 3 because the negatives cancel, which is about 4.3 if you check on your calculator. Because I'm doing this by hand, the 4.3 will be more useful to me than the fraction. Even though I said we should leave things in fractions, that's for the final answer. But when I'm graphing, I'm going to need that decimal. Okay, so now what I can actually do is go through and start making my graph. And so what I want to do is draw the straightest line I can. It's probably a little bit easier to do on paper. So that's my y-axis. Draw the straightest line I can. And that's my x-axis. Okay, so when I decide on the scale here, we have 13 as the biggest, and that's on the y-axis. So probably what I'll do is I'll count out so that I just get it in there. So there's my 13. And maybe on the x-axis, I don't have to go too crazy. We only go out to 4.3, but I don't want to go that much different. So I'm just going to count out to 10. So I'm going to do the same thing here. Everything else is going to be 10. So let's see, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to just label it so that I know where things are. And I want to label it so that other people know what I did too. So I'm putting the 10 there because 13's up there. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. And then there's my negative 10. Okay, so let's look at each of these and we'll label them with the numbers as we go. So I'll do 1 in orange. And so 1 had an x-intercept of 4.3. So that'd be just a little bit past 4. So there's my x-intercept. And a y-intercept of 13. So right there. Okay, so if I connect these two with a line, then I'll have my approximate graph. Okay, and just imagine that being a straight line. Now for my other one, 3 minus x, and so that's 1. I'll do that in green. It won't be the prettiest picture. We have a x-intercept and a y-intercept of 3. And so now I'm going to draw that line. As best I can. And already you're seeing some of the trouble when you work with this type of stuff by hand. Of course, I'm going to have more trouble drawing on a pad like this instead of paper. But in all cases, look at my scale. It's a human-made scale by hand. It's not going to be perfect. Look at my lines. I mean, they really don't look like lines. So when I get my answer, it's not going to necessarily be perfect. That's why we have this idea of using technology as well. And so now the intersection point should be the solution. If I was looking at my scale, 1, 2, 3, 4, looks like about 5. And minus 1, minus 2, it's kind of hard to tell. I actually solved this earlier. The solution is, in fact, 5, comma, minus 2. And with my imperfect scale, it's kind of hard to tell, is it minus 1 or minus 2 here, but this is the correct. And you can see my graph shows that approximately. So my recommendation when you're doing something like this is to perhaps use graph paper or something like that, or draw very carefully with rulers where you can get a nice picture. But as you can see, this trick up here, this trick is going to be very, very useful when we graph these later on, especially when working with inequalities.